Hello and welcome to my course titled Bipolar Junction Transistors Part 1 Fundamentals. I am Siris Brahmanyam and I will be your instructor for this course. With over 5 years of professional experience in power electronics, analog electronics and circuit design, I bring practical insights to the subject. As a way of giving back to the power electronics community, I share the knowledge I have gained from my experience in the form of detailed design courses. These courses cover various aspects of design, practical examples, insights, field issues, and much more things that are not often taught in the college and are usually learned the hard way by engineers in the job. Depending on the course type, I also provide various knowledge check quizzes, Excel calculators, simulation files, and references to help students easily understand and correlate with the concepts and follow along. This transistor course series consists of 4 main parts and 1 associated course. The first part of the series is this current course titled Bipolar Junction Transistors Part 1 Fundamentals. As the name suggests, this course focuses on the theoretical aspects of transistor as a device. To reinforce your learnings, Part 2 of this course series titled Bipolar Junction Transistors Part 2 Problem Solving presents various problems related to transistor operation and its common applications. This helps students correlate and reinforce the theoretical knowledge gained in Part 1. Part 3 of this course series, titled Bipolar Junction Transistors Part 3 Applications, discusses on the popular applications of bipolar junction transistors used in power electronic applications. When it comes to transistors, designing the drive circuit is one of the most challenging topics. It is not as straightforward as designing a MOSFET gate drive circuit. Therefore, Part 4 of the series covers transistor drive circuit design in detail. Together, these 4 parts cover all the essential aspects of transistor operation and its applications. The final course in the series, titled Fundamentals of Semiconductor Device Physics, helps students understand the fundamental concepts related to semiconductor device operation and underlying operating mechanisms. As transistors heavily draw their operating mechanism from the PN junction devices, familiarity with diodes forms a prerequisite for this course. If you are looking for a detailed course on diodes, I have one featured course available on my instructor page. This course comprises of 12 modules, each carefully designed to enhance your understanding step by step. Module 1, Introduction to Bipolar Junction Transistors. This module introduces the basic concepts of transistors, establishing foundational knowledge without delving too deeply into the mathematical equations. Module 2, Circuit Configurations. Here, we cover all the possible transistor circuit configurations and focus on the most commonly used ones in practical applications. Module 3, Operating Mechanisms. This module explains the internal operating mechanisms common to both signal and power transistors. Module 4, Static IV Characteristics. Here, we will discuss the static IV characteristics of transistors and other relevant concepts including early effect, quasi-saturation, conductivity modulation, and hard saturation. Module 5, Dynamic Characteristics. In this module, we examine the switching characteristics of transistors in detail, considering both resistive and inductive loads. Understanding these characteristics is very important when using transistors in power electronic applications. Module 6, Miscellaneous Topics. Here, we will explore various concepts related to transistor operation, such as paralleling operation, unipolar operation, base spreading resistance, Darlington configurations, and power loss calculations. Module 7, Breakdown Mechanisms. This module covers various breakdown mechanisms that can occur in transistors during operation, including the second breakdown in power transistors. Module 8 Simulation Models. Here, we discuss the popularly available simulation models that help users simulate the characteristics and performance of transistors in different applications. Module 9 Understanding Datasheet Parameters. Here we will explain how to read and interpret the datasheet of a transistor provided by the manufacturer. Module 10 Thermal Characteristics. This module explores the thermal model of the transistor, including junction temperature calculations, along with a focus on its safe operating area and transient thermal impedance. Module 11 Applications, Testing Methods and Interview Questions. Here, we highlight the current applications of transistors, transistor testing methods, and include some interview questions to help you assess your learnings so far. Module 12 Course Conclusion and Reference Documents. In this final module, we wrap up the course and provide a list of references for further reading. As your instructor, I am here to guide you through this exciting journey and help you build your expertise in power electronics. In the growing age of artificial intelligence, investing time in skill upgrades is the only key to stay ahead of the competition. My goal through these courses is to help power electronic engineers around the world become more skilled at their work. I hope this course helps you improve both your academic career and your performance at work. Thank you for investing your valuable time and trust in this course. Let us get started.